Hello friends, today I'm going to talk about trunking. What is it? So, if I talk about this access ports, I would say a switch, any port which is connected on a switch is actually access port. So for example, you have a printer here and you have any other device here connected. So all these, you could say a PC. So all these ports are basically access ports, right? But when I talk about trunking trunk ports are the ports which connects to a different switches. For example, this switch connects to another switch, switch 2. These are known as the trunk ports. Please bear in mind, these are the trunk ports. Okay. Now today we're gonna see the practical for this, the how the traffic flows from the access to the trunk and to the other access. So in our practical, what we will do, we will take two switches, switch 1 and switch 2, that you can say in the example. We will create VLAN 10, and also we will create here also a VLAN 10. And then we will ensure the traffic from this PC to the PC which resides in VLAN 10 flows properly. Let's see via a practical. Okay, so what we need to do is that we need to take here one switch. Let's take this switch, and that's the switch. So here we can say this is switch 1, okay, and this is, let's say, it's called as switch 2. Let's connect two PCs here, PC 1, okay, and let's consider it to be under VLAN 10. Similarly, let me take two more PCs and let me just connect them to, again, I say VLAN 10. How do we could connect? We just take a wire from here, put it here, take it from here, and connect. Okay. Initially, if you see, they are orange because STP protocol runs and switch takes a few seconds before it recognizes, okay, this is a PC connected to it. Now I can turn it to green. So if you see, we can wait for some seconds, and you will say it will turn into green sooner. Let Meanwhile, let's connect the PC. It will also be, if you see, it is also taking some time before it. So here you can see the all the both the ports are turned into green, right? Now the ports are in the block stage. Orange means it is in the block stage initially, so then it turns into green. Now these two pieces will take in VLAN 10, and these two will also be in the VLAN 10. Fine. Let's take two more PCs here, and let's connect. And let's consider this as VLAN 20. Okay. And similarly, let's connect two more PCs here. Now we can just move it a little bit here, and then let's consider it to be under VLAN 20 here, this one also. Okay, now this VLAN 10 here should able to communicate with this VLAN 10 here. How? Let's connect a wire between two switches. Now if you see here, this is one single wire, but we should take two wires for the redundancy purposes. So what we're gonna do is that we will take another wire from here and it will connect it here. So you will see. But if you see here, they all are orange, but soon three of them will turn to green, but one will continue to remain orange. And the reason is spanning tree protocol. I will not go deeper into this in this video, but I just want to tell you that, see, if you see, both have turned green, but one of the ports from these orange will also turn into green. So what spanning tree does is that it avoids the loop. So you see here, it avoids the loop, which means that it avoids the loops that can happen between the two switches. So to avoid that, one of the port will continue to remain in the orange state, which means it is blocked. Great. But that's not the purpose. But still, just to explain you what spanning tree does. But if let's now configure the switch. Let's go here and let's configure it. So what we're gonna do, we say config 3. So I've just launched in the screen. Now switch 0 is this switch 1. What we can do is we will actually run hostname and we will say hostname switch 1. So this hostname of this particular switch is now switch 1. Now we will actually say int range and we will, so if you see, it's switch FA01 and FA02 here, right? So what we're gonna do, we're gonna say okay, fine, int FA/1 hyphen 2 int range, fine, and we say switch port mode access, as we say these are the access ports, and then we say switch port access VLAN 10. Great. Now the VLAN 10 does not exist, so it has created a VLAN 10. You can actually name also, so you can say VLAN 10, and you can name it to, let's say, some management VLAN, just for your own convenience. So if you go out, if you see VLAN brief, you will find, in my previous video I showed you about that what the show VLAN brief does. So that in the VLAN 10, two ports 1 and 2 from default VLAN 1, from here from default VLAN 1 it got removed and it has been added here in VLAN 10, this FA01 and FA02. Fine. Now let's do for VLAN 20 as well. So what are those ports which are on VLAN 20? So it's 3 and 4, right? So let's go here and do that. VLAN 20. Sorry, we need to go to the terminal. 20. Name it, let's say, storage VLAN. And we can say int range FA0/3 4 2, and then say switch port mode access. Then can say switch port access VLAN 20. Fine. So both of these switches are also in VLAN 20 now. This is switch 1. Let's go and configure the same settings in switch 2 as well. So what we're going to do, we're going to go to switch 2, enable, see, we say hostname here as SW2. Okay, we said yes, it's switch 2. Now if you want to see the show VLAN brief, none of the ports been added in any of the VLANs. So if you see here, yeah. So what we're going to do is we'll take 1 and 2 and 3 and 4 and move to VLAN 10 and VLAN 20 respectively. Let's see how it is. If we see VLAN 3 and 4, VLAN 3, yeah, VLAN 2, yeah. Okay, 1 and 2 will go to this, and 3 and 4 will go to the other one. We created 2 VLANs, right? No, we haven't. So we say VLAN 10, and we name it as MGMT. And we say VLAN 20, and we name it as storage VLAN. Great. Now what we're gonna do, we go int range FA0/1-2, which means these two ports will be added to VLAN 10. So how we're gonna do, we're gonna like this, switch port mode, we convert them to access ports first, fine, and then we say switch mode port access VLAN 10. Okay, great. Now we do a similar thing for other two ports. Brilliant. We have done this. So all the ports, these two PCs are this VLAN 10, and these two PCs, then these two ports, or the PCs are in VLAN 10. But and now what we're gonna do is that we will actually convert these two ports into trunk ports. How? Let's see. So we go back to switch 0, or you can say switch 1. Switch 1 is this one, right? What we're gonna do is we say fine, int interface range fa0 slash 5-6. So you can see this is 5 and 6 ports, and we say switch port mode trunk. That's it. Okay. Now similarly we'll do for this switch 1 as well. So we go here, we say, sorry, switch 2 here. We say int range fa0. Great. Now all these ports have turned into trunk, and we have the access ports. Now what we're going to do is we need to define what is VLAN 10. So we can say so VLAN 10 is 192.168. This is just an example. 0/24. Okay. Now similarly we can say for this one, this can be 20. So it's another subnet because this is VLAN 20. This is VLAN 20. This is VLAN 10. So we should have this also as, sorry, we should have this as also, yeah, this is this, and this is this. Fine. Now let's assign IPs to these PCs. Let's go there. 192.168.10.2. Okay, and this is at 192.168.10.3. Okay, and this because this is a part of the VLAN 10, so it will say 192.168.10.4. Fine, and this as again 192.168.10.5. So all these VLAN 10 are PCs have been assigned as per their own subnet, right? They're assigned 192.168.10.2345. This is how it is. Now the important thing is here, like then now we have converted this as trunk ports, we have converted this export. Now it should ping this. So let's see how it will work. So before it does, let's go to the simulation mode and do one thing. Let's see both the ARP and the ICMP packets. Let's see that how it works. If we go here, we don't see any ARP entry. Okay, it's all there. It's nothing is there, right? And if we go to here, and if you want to see any MAC entry, to do is that you can just clear it in this switch, and here also you can actually clear the MAC entry. Okay, so basically what you have done is that, okay, there's nothing here in this. Okay, there's nothing in both the no MAC entries, no addresses. Fine. What we're gonna do is now we will try to ping from here. Let's try ping 92.168.10 dot, sorry, 10.5. So what I'm doing is that if you see here, this is 10.5. You can see it by checking its configuration. 10.5, right? Okay, great. And this one is your 2. Okay. Now what I'm doing is that I will try to ping from here to here. Let's go to the simulation mode. If you see here, the simulation mode, and let's try to ping from this PC to 10.5, this PC. Let's see what happens. So ICMP packet starts. Now it sends an ARP request. Now the request, this is the ARP request which has flown here. Now if you look at this ARP request here as switch 0, it says, well, inbound packets, okay, this has come as an ARP request to me. But if you look at the outbound, it says TP ID is 81 and TCI is 00A, which means if you see, these are the this value, these two headers actually tell you that this is a VLAN tag packet. This is basically 802.1q VLAN tag headers in the Ethernet header basically. So if you see, inbound was just Ethernet and outbound is 802.1q because there are new headers that has been added, TPID and TCIe and TCI, right? And these are both are 4 bytes. Okay, together there are 4 bytes. Anyhow, now what's going to do is that it will go further here. Now let's see what has happened. That it has sent a packet to its own, I mean, it has broadcasted, but it into its own same VLAN, which means that VLAN is also known as, we can say a VLAN can also be known as broadcast domain, because it has created a domain, a broadcast domain of VLAN 10. So therefore, this switch only send it to here, and also it send it to trunk ports. Now let's see what happens next. It will only send it to the VLAN, both of the computers which are part of the VLAN 10. But as you know that 10.5 will accept this packet because this packet was only for 10.5. Now let's see what happens. It will, let's turn it. So the packet goes back, it returns here. Now not the packet but the frame actually. And it comes here, back to its. So if you see, now if you see, ICMP has now started. So if you see here, you don't see the ICMP response, even though, so this response is only the ARP response. So ICMP has not yet completed. ICMP has now initiated. So what has actually has happened? If I just stop this, if you see ARP hyphen hey, you would see in this particular PC it has this IP address. So it has the IP address of, it has an IP address of this PC, and also it has the MAC address of this PC, which it didn't have it earlier, and therefore the ARP was sent. ARP was sent from here. Why did we did the ping, but why did ARP initiate it? ARP initiated because this computer lab PC wasn't aware of the MAC address of the destination router. So in this case, we also it also clarifies that a PC can work as a router. If you see, this is an IP address of this PC. So we can also say the PC works as a router, right? Now, if you want to see it, if you want to see ping again. Now let's see what happens. Now basically you can just see it in the real time. And if I move it to the real time, you will see, yeah, see, it can ping, it can ping it, it can ping it, it can ping it. So this PC in the same VLAN can ping the PC on the other switch on the same VLAN, and this can only happen through the trunking. The other interesting part here is that why did I use two cables here? The reason is redundancy. So if you see this port, orange one is blocked, right? What I can do is I can just block this one, the one you see in the green, which is FA05, and let's see what happens. This FA06 will turn into green. Let's see what happens. So I go here. What I'm gonna do, I'm gonna shut down this port. Let's see what happens. I shut down this port. Do you see? I shut down this port. But this will, the orange one will turn to green. Let's wait. Let's wait for some time. Great. Now you can see that it has turned into green. Now if you try to ping from PC0, again if you try to ping, it will be successful because now the traffic will actually go from this, right? From this, the redundant link. So you understand the concept of trunking here. You also understand that why did we use two cables here between two switches? Because of the redundancy purposes. So this practical shows you how two VLANs can communicate over a trunk line between the two switches. Thank you very much.